In this video, I will be showing you how to use the polynomial identity that we derived from dividing by x minus a. We're going to be using this identity down here, that x to the power of n minus a to the power of n divided by x minus a equals this stuff over here. We're going to be using this identity to help us factor very large numbers. I'll show you an example. Okay, there are two things we need to consider before we go into the examples. The first thing is to recognize that you can rewrite any division number expression as multiplication. I'll give you a numerical example. So let's say I have 15 divided by 3 is 5. I can actually rewrite this as 15 equals 3 times 5. If you just cross multiply, or just recognize that if you divide a number to get the number back, you multiply. Okay, so 15 equals 3 times 5. This is the form that we're going to be using in this video, in this skill. All right, so now the other thing you need to recognize is that this 3 is a factor of 15. In the same way that 5 is also a factor of 15. All right, so these two factors, 3 and 5, multiply to become 15, the product. So the product of these two factors is 15. Two factors is 15. So recognize that if we are able to write an expression such that we can say it is something times another thing, this will be a factor, the other thing will also be a factor. Those are the basic consideration. All right, let's apply that to our identity now. All right, so kind of erase this off. I can't. Okay, here we go. Now let's go back to this identity. We see that this is a division setup. Now it's been turned to multiplication setup. See, by multiplying, this x minus a multiply goes up here, this goes up here, and then you have that. So basically they are the same relationship, except this is division and this is multiplication. We're going to be using this fact, this idea, on the next screen. Okay, here is an example of a very large number. This is not too large, but we're going to see even larger number than this. 3 to the power of 4 is 81, minus 1 is 80, so it's not really too large. But this little example will help us to see the basic understanding of how to apply this identity to factor this. All right, so the first thing you need to recognize is that we need to rewrite this expression to look just like this. So we already have this right here. This is our x to the power of n, okay, and then this is our a to the power of n. But it doesn't have an exponent though. This one has no exponent, just like this one. But you have to recognize that 1 to the power of anything is also 1. So we can actually rewrite this 1 as 1 to the power of 4. 1 equals 1 to the power of 4. So on the next screen, I'm going to show you that this expression can be written like 3 to the power of 4 minus 1 to the power of 4, which matches x to the power of n minus a to the power of n. That is the idea, just being able to rewrite whatever is given to you to match this left side of the identity. Okay, so the next screen now, I'll show you how this is being converted to that. So there you have it, 3 to the power of 4 minus 1 to the power of 4. Now our next job is to actually apply this formula now. Apply this formula with this. Okay, you're going to recognize that the 3 to the power of 4 is like our x to the power of n. So our x is actually 3. So our x is 3. Our x is 3. And our a is 1. A is 1. So for any of these problems, if it's a challenge to you, I will ask you to always try to determine what is x by comparing. If you compare that to that, all right, our x is 3, our a is this number, that's 1, and our n is 4. So we need to write our n is 4. All right, if you sort of get these three things out, from the problem by comparing, then you're on your way, you're set. So now we're going to just plug in these values over here, we're going to plug them into here and here, okay? All right, let's start off. So we're going to say 3 to the power of 4 minus 1 to the power of 4 is 3 minus 1. Remember that we said that x is 3, a is 1, and n is 4. Okay, so we're just plugging in now. So we go x minus a, 3 minus 1. That's the 3 minus 1 right here. 3 minus 1, that's x minus a. Then we go to x, n minus 1. So n is 4. 4 minus 1 is 3. So we have 3 to the power of 3 because x is 3. And then a is 1. Our a is 1. This is 1. 1 to the power of anything is just 1. Or 1 is just 1. So 1 times that. Then we go down in the exponent for 3. And then we go to the next one. Our a is 1. 1 square is also 1. And then x to the power of, which is 3 to the power of 4 minus 3, which is 1. And then we go on until we got x equals to 0. So we just go until it becomes 1 at the very end, until our n equals 0 at the very end. So we just have the power of 3 going down. 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, and then 3 to the power of 0, basically. So you start off by subtracting 1 from here, which is 3, and then you just go down on the values, basically. If a is 1, this is just what you got all the time. So now, like I said before, this is a factor. This is another factor. So we have two factors from this expression. This is one factor. This is one factor. This is another factor. Okay? Of this. So this has two factors. It has one factor times another factor. So then we can make our conclusion then that 3 minus 1, which is 2, is a factor of this big O number. 2. So that's our conclusion. 3 minus 1 is 2. This minus 1. This is one factor of this. Now, this is very, very basic. As we go to the next example, you're going to see how these values are changing, okay? All right, here we go. Now, there's one more thing, though. If I wanted to find another factor of this number, then I have to do something else. Okay, so I want to find another factor of this expression. This is where we have to think a little bit. We have to rewrite an expression. So we're going to change this thing right here to another exponent. All right. Now I want to help you to see how we can change that. First of all, you have to recognize that 4 can be written as 1 times 4. 4 can be written as 2 times 2. So the goal is to actually change this 4 up here to 2 times 2. So we're going to read that like this. 3 to the power of 2 times 2 minus 1. Okay, that's our goal. And then, based on Algebra 1 concept, we know that these two actually can be taken inside here. So to look like this, 3 to the power of 2 to the power of 2 is the same as this. This is the same as that. We just brought in this 2 as the exponent of 3. So now we can actually write this as 9 because 3 to the power of 2 is 9. So 9 squared minus 1. So effectively, we have rewritten this original expression as 9 to the power of 2 minus 1. So now we have a new form. We have a new form now. This new form is going to help us find another factor. So rewriting the first original form to another form allows us to be able to find another factor. That's your goal. All right. This you have this explanation I've given to you already, and then you have that is the new form, okay? Compared to this, your skill, you're going to develop your skill of being able to change any form to another form by manipulating this number there, basically. All right? So here we go. We're going to apply the formula to this now. Our new A is 1, is still 1. Our new X is now 9, not 3 anymore, because this is what we're going to be working with. Our A is 9, okay, and our X is 9, our A is 1. So that's the next question. So here we have it. So we have the A, this is our X minus A, and that's the X minus A right here. That's the first factor. Now, this is second factor. Usually, because we are looking for a factor, we do not really actually have to bother ourselves with this second expression here. All right, second factor here. We just need to find what is 9 minus 1, okay? So we're just going to find what is 9 minus 1. So what is 9 minus 1? 9 minus 1 is 8. 8 times blah, blah, blah. Whatever that is there is another factor. This is one factor. This is another factor. So 8 is really another factor of this. 8 is one factor of that. So there you have it. 9 minus 1 is 8. Another factor is 8. So now we found two factors. We found 3 minus 1. 2 was a factor. And then 8 is also a factor. All right. So you may be asking me, can we use this method to find one more factor? That will be hard to do because we could not basically break up this 4 anymore into another smaller factor. So we've broken it up already into 1 times 4, 2 times 2. I think basically we are done. We are not able to use this method to find another factor apart from 2 and 8. All right. Now, the next example, you have 5 to the power of 10 minus 1. So we're just going to apply the formula straight away. We just rewrote it as that, and then we're going to have a formula. Here is the formula. So this is our X is 5, and this is our A. So our X is 5, and our A is 1. And then we are plugged in X minus A. So this is my X and this is my A. And like I said before, we do not really need to bother ourselves about this other one or evaluating this one. It's just sufficient to plug in a few values into it and then write it like that and leave it alone. So our new thing is just going to be 5 minus 1, which is 4 times some blah, 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 blah. Okay, 4 is a factor. As you can tell from the previous example, that we can actually break 10 up into 1 times 10, 2 times 5. So it's possible to use the same method to find another factor, I think, which is our next example. By that idea, we can break 10 up into 1 times 10, okay, or 2 times 5. And that's how we're able to use that to break up this. We're able to break up this, all right, into 2 times 5. So that what's inside here now is 5 squared to the power of 5, which is actually here is 25. to the power of 5 minus 1 to the power of 5. So we now create another form from the original form, from the original expression. From this guy, we got a new form, which will allow us to find another factor, which obviously you can see 25 minus 1 is 24. Okay, but we have to still write everything out like this out. So we're going to write everything out. So this is a new form from the old form, and then we out. So everything is written out now. You must always rewrite everything out. Do not just say, oh, I see the answer is 25 minus 1. No. You must go ahead and write everything out, because you are basing your solution on this identity. So your reason for being able to say that the answer, one of the factor is 24, is because of this identity. That is why you must always include this identity in your answer. So that's how we know. You must always write this identity all out to show that 25 minus 1, 24 is another factor. All right. Now the next example allows us this next example, which actually is not there. All right, so I want to show you one more example of using this. So here we go, another example. Okay, I have a number that can be broken into many more patterns. So let's say I have 2 to the power of 12 minus 1. Say this 12 can be broken into 1 times 12, 2 times 6, 3 times 4. All right, so this is 1 times 12. Sorry about that. And then I think so we can actually get 3 factors from here. So the first one will be 2 to the power of 6 minus 1. The second one will be 2 to the power of 3 to the power of 4 minus 1, which we can actually rewrite like this. I want to rewrite it over here. So we're going to rewrite it down here, just to kind of solidify the idea in your mind. This one is 2 minus 1 is 1. This one is 4 to the power of 6 minus 1 to the power of 6. Well, I'll just keep this one as 2 to the power of 12 minus 1 to the power of 12. And then this one will be 2 to the power of 3 is 8. 8 to the power of 4 minus 1 to the power of 4. So from these 3, we can tell that 2 minus 1, that's one factor. 4 minus 1, that's 3, another factor. 8 minus 1, that's 7, another factor. So from these 3 ways of writing the same thing, 1 is a factor, 3 is a factor, and 7 is a factor. Hopefully this is this kind of clarifies this idea for you. And if there's any other question, please let me know. Thanks. Bye-bye.